All compounds have energy stored in them. So where you've got compounds, that's different elements bound together, compounds have energy stored in their bonds. It's called chemical potential energy. You may have heard of potential energy being energy that's waiting to be converted into something. Like a car sitting at the top of a hill, it's not doing anything. It's got the potential to do something, though. It's got the potential to roll down the hill really fast, in which case its energy would be changed to kinetic energy. Now, chemical potential energy has the potential to release energy stored in its bonds, and it's generally released as heat or light energy. But it's transformed. If you get some gasoline and set it on fire, you release the energy that's stored inside the gasoline, and it gets transformed mainly into heat, but also some light. Chemical energy can also be released as light energy. You'll know your glow sticks. That's a chemical reaction releasing energy as light. So, going back to our gasoline, okay? We've got our gasoline. If we draw a graph of the energy, we can say we've got energy and time. I'm sorry, it's curly. Okay. Now, when we start, our gasoline's got lots of energy stored as chemical potential energy in its bonds. And it's just sitting there with all this energy as time goes on. And then we add a little bit of energy with a match. So there's more energy, and then it quite quickly releases its energy until it's only got this much, because this is carbon dioxide and water. That doesn't have as much energy in it. This is our gasoline. So you can see there that we had lots of energy. Now we don't have lots of energy. The energy was released as heat. So the energy came out of it. We call that an exothermic reaction. Exo. Sounds a bit like exit, doesn't it? Exo, exit. The energies, the heat energy, the thermal energy is exiting the compound, the reaction. And with all that heat energy coming out, you can feel it. It feels hot. Now then, some reactions start with very little energy in them. They start with just a little bit of energy. And once the reaction starts, they soak up energy. So the energy is going into the reaction. So this time, instead of an exothermic reaction, we call it an endothermic reaction. Endo. Because the energy is going in, and it's thermal energy. And this time, because it's sucking the energy out of anything around it, if you've got your hand on it, it sucks the energy out of your hand, which makes it feel cold. So we've got an exothermic reaction with the heat energy coming out of it. It comes out, it warms up everything around it. It feels hot. An endothermic reaction has energy going in, and it feels cold because it's sucking the energy out of anything nearby. You'll see that in an exothermic reaction, you finish up with less energy than you started with. In an endothermic reaction, you finish up with more energy than you started with. In the next lesson, we're going to look at how we calculate how much energy goes in and how much comes out.